This video is part of my video course that teaches how to test Java with JUnit and Mockito. For other video lessons in this playlist, check description of this video. So, what is a unit test? Unit test is a very small, self-contained method that you write to test some part of your code. Let's say you have a method in your Java class that needs to be tested. To make sure that this method works as expected, you will need to write one or more unit tests. Each unit test is a very small Java method that you create. It is a small piece of code that you write to invoke the method you are testing. In this particular example, I'm testing a method that is called isEmailValid, so the JUnit method that I will create will invoke the isEmailValid method and it will validate that it has produced an expected result. To test application code, we usually write more than one unit test. One unit test will test your method with valid parameters, while another unit test will intentionally provide your method with invalid parameter values. And in both scenarios, your unit test methods will validate if the method you are testing produces expected result. Now, the code in unit test is very simple and is usually very short. And this is why on my slide on the right side, I have illustrated each unit test as a much smaller element than a method it is testing on the left side. The method on the left side may contain a very complex business logic, and this is why on my screen this element is represented as a very large element. So a unit test is also a code that you write, but it is very small and is very simple code that does not contain much of a business logic. It is very simple code because all it does is it calls your method under test with specific input parameters and validates the returned result. And it is very important to keep in mind that unit test should be testing one particular functionality only. We should not try to make one single unit test method that tests multiple methods of your class at the same time. So to write unit tests, we will use JUnit. JUnit provides us with an API to write small code snippets to test our Java methods. Now, your Java application may contain many classes, and each class may contain several methods. To ensure that your application is well tested, you will want to write more than one unit test for most of the methods in your class. When you run unit test and it successfully passes, it will be marked with green color. But if unit test does not receive an expected result and it fails, then it will be marked with a red color. This is why on my slide I have some unit tests colored in green color and some unit tests that have failed colored with the red color. Now let's zoom in and have a look at an example of one single unit test. Now let's start with a very simple code example first, and then as we become more comfortable with unit testing, we will look at more complex code examples. Let's assume that we have a Java class that is called calculator, and it has a very simple method that is called integer division. It has a very simple business logic, and all we do here is we perform math division, and we divide one number by another. But even though it is a very simple code example, this method can still be tested. For example, what if a developer made a typo and instead of division, performed multiplication or addition? So we can write a unit test to make sure that this code works correctly. And to test this method, we can write unit test that will look something like this. Now, we will talk about test method structure and all of its details in following video lessons, so please do not worry if it looks a little bit strange or confusing to you. For example, you might have noticed that the method name looks very unusual. It is very long and it has test annotation. But don't worry, we will talk about it in the following video lessons. Now, this method is also divided into three main sections. The first one is called arrange. In this section, I create a new instance of calculator class. The second section is called act, and in this section, I actually invoke the integer division method and provide it with two valid parameters. Now, the integer division method is the method that I'm testing. It is called method under test. And I want to make sure that this method works as expected and it performs integer division correctly. So I give it two parameters and I capture the returned value into a new variable that is called result. The third section is called assert, and this is a section where I use special JUnit methods to verify that the result is correct. 4 divided by 2 should produce 2. So I use a special JUnit method that is called assert equals to verify that this result is correct. The first parameter that it accepts is expected value. I'm expecting the result to be equal to 2. The second parameter is an actual value that was returned from integer division method. And the third parameter is an optional hint error message that will be printed in the console if this test method fails. Alright, so if 4 divided by 2 does not produce 2, then this unit test will fail and the message 4 divided by 2 should have returned 2 will be printed in the console. Now, don't worry if it is still a little bit confusing at this moment. In the following lectures, we will actually write this unit test in our development environment and we will run it and we'll actually see how it all works. If I run unit test in my Java development environment, like for example IntelliJ, and if this unit test passes, then I will see a green mark on its left side. But if my integer division method did not return expected result and my unit test fails, then I will see a red mark on its left side. And there will be also more information printed in the console and also in the test result panel. Now, different development environments will have different user interface for test report, but the successful unit test will always be green and the failed unit test will always be red. So unit testing is a process where developers write and then run very simple test methods that test individual parts of our application. Unit tests are very small and they run very fast. They run very fast because when testing a method, any dependencies that this method might have are replaced with mock objects. For example, if the method I'm testing sends HTTP request and depends on HTTP client object, a real HTTP client object will need to be replaced with a fake or mock version of it. And there can be different kinds of these fake objects. There can be a fake object, there can be mock object, or there can be a spy object, and we will talk more about these different kinds of fake objects later in this video course. So real HTTP client object will be replaced with a mock version of it, and no real HTTP request will be sent. And this will make our unit test method run much faster. And we do it because unit test method is not actually testing how HTTP client works. Unit test is focused only on testing Java code inside of the method that you are testing. If the method you are testing depends on another object, that dependency will need to be replaced with a mock object. And when all external dependencies are replaced with mock objects, with predefined behavior or with hard-coded values, then the method we are testing will work very fast and our unit test will also work very fast. And this is why, if needed, I can write more than one unit test to test a single method. For example, one unit test will be to test method with valid input parameter values, another unit test will be to test method with invalid input parameter values, and another unit test can be to test methods with invalid response from HTTP client. You can write different unit tests to make sure that the method you are testing works well and reliable under different conditions and always produces expected result. So why do we want to write unit tests? It's very quickly to run our application and just do manual testing to make sure that things work. So why write code to make sure that another code works? Why not test manually? And there are a few very big advantages of writing unit tests to test our code. We write unit tests to make sure that our code works now. This is obvious, but this is not the biggest advantage. One of the reasons why we want to write unit tests is to make sure that the Java method we have written works well with different input values. We want to make sure that it works well with valid and invalid input parameters. Now, we can do manual testing and manually provide valid and invalid input parameters, but if we have a very large application with many features, then it is very easy to forget to test one of the features with one of invalid parameters. Especially when we have many developers working on a project, when changes to our application are made on daily basis, and when we need to do frequent tests. Manual testing of application that has many features becomes very difficult, and it becomes very easy to forget to test a feature with a specific invalid input parameter. Another very big reason why we want to write unit tests is to make sure that our code works well now and in the future. Imagine that you have written a very complex method. This method is very useful and other developers started using it in their classes as well. How do you make sure that other developers who want to make changes to your code do not break anything? Unit tests that you have written for this method will give you confidence that future changes to this method do not break existing functionality, and that this method still works as expected with all valid and invalid input parameters as it used to work before. It is also called regression testing, and unit tests help you feel more confident that new code changes to existing application features do not break other working code. If you make changes to one of the methods and it breaks functionality in another existing and well-tested feature, then it is called regression. So you will want to write unit tests to make sure that there is no regression and all features still work as expected, even after you made a small change to existing and well-working code. When writing unit tests, developers try to, as much as possible, follow the first principle. It is a combination of multiple principles, and in this lecture you will learn about these principles. The first letter in the first principle stands for F.I.R.S.T. Unit tests are small pieces of code that perform one specific task. Because unit tests are small and unlike integration tests, unit tests do not communicate over the network and do not perform database operations. And because unit tests do not communicate with remote servers or databases, they run very fast. The next letter in the first principle stands for independent. Ideally, unit tests should be independent from each other. One unit test should not depend on the result produced by another unit test. In fact, by default, unit tests run in order that is not obvious, and we do not really know which unit test will run first and which unit test will run second. The code you are testing, or the system under test, should also be isolated from its dependencies. And this is to make sure that the bug in a dependency object does not influence a unit test. So dependencies are usually mocked or stopped with predefined data. And this way, unit tests can test a system under test in isolation from its dependencies and produce a very accurate result. The next letter in the first principle stands for repeatable. Unit tests should be repeatable, and if I run the same unit test multiple times, it should produce the same result. If unit test is run on a different computer, it should also produce the same result. This is why unit tests are made independent from environment and from other unit tests. The input parameters that the method under test requires are usually predefined and hard-coded. And if method that you are testing needs to be tested with valid and invalid input parameters, then you will create 2 or 3 different unit tests. Each unit test will test the method under test with its own set of predefined parameters. And this way unit test becomes repeatable, and if we run it multiple times in different environments, on a different computer or a different operating system, it will still produce the same result each time we run it. The next letter stands for self-validating, and this means that to learn if unit test has passed or not, developers should not be doing any additional manual checks after the test completes. Unit test will validate the result that method under test has produced itself, and it will itself make a decision whether this unit test is passing or is failing. So after unit test completes, the result will be clear. And the next letter stands for thorough, and developers who practice test-driven development will also spell it as timely. Talking about thorough, this means that when testing a method, we should consider happy path as well as negative scenario. And this means that most of the time we create multiple unit tests to test a method that accepts input parameters. One unit test will test your method with valid input parameters, and another unit test will test your method with invalid input parameters. And if there is a range like minimum and maximum value, then we should create additional unit tests to test for minimum and for maximum values as well. And talking about timely, it means that it is better to create unit tests at the time you're working on application feature. This way you'll have more confidence that the feature does work as expected, and there are less chances that you will introduce a bug and that bug will be released to production. So before you promote your code to production, it should be covered with unit tests. One of the main principles to follow when unit testing a method is that we need to test this method in isolation from other dependencies. Let's have a look at a little diagram to understand what this means. Let's consider that we have a class with two methods, and that we need to write unit tests for method A to test if this method works well and returns expected result. Our ideal scenario is that method A has a single responsibility and that this method is isolated from any other external classes. If it is isolated from external dependencies, then our unit test can easily create an instance of this class and call its method to verify if it returns expected result. But very often it's not the case. Often method A creates an instance of another object, and to do its work, method A needs to call one or two methods that belong to another object. And this complicates our testing very much, because if a failure takes place in method that is in a different object, the unit test will also fail. And since our unit test was testing method A from object A, we might mistakenly conclude that it is method A from object A that is misbehaving, while the actual error is taking place in a different method in a different object. So to avoid situations like this, we need to isolate the code we're testing. We create unit tests to test business logic inside of method A only. And since we're only interested in testing code in method A, we need to find ways to isolate method A from other dependencies and test it in isolation from code in object B. Let's see how we can do it. To make our code better testable, we need to use dependency injection. Let's say we have an object A that depends on code in two other objects, B and C. Currently, object A creates a new instance of class B and class C in one of its methods. So instead of having object A creating a new instance of class B and class C, we will need to flip this relationship around and inject into object A ready-to-use object B and object C. And this is called dependency injection. When dependencies are injected this way to isolate code in object A from code in objects B and C, we can write unit test that injects into object A a fake or mock implementation of code in object B and C. This way we can test code in object A in isolation, and this way we prevent situations when a bug in code in object B fails code in object A. Injecting mock implementation instead of real dependency helps us isolate code that we need to test and test it with different kinds of input values. If we need to test our method with a range of different input parameters, valid and invalid, we can create a unit test that works with mock implementations of those objects, or even simple stubs that do not really do any business logic. You will learn how to create mock objects and how to create stubs in following video lessons, but for now it's very important to understand that when our code under test has dependencies on other objects, we need to use dependency injection and inject mock implementations of those objects so that we can test our code in isolation from those dependencies. Let's have a look at little code example. I have a method that is called processUserSignup. Inside of this method, I create a new instance of SignUpWebService class. So instead of our method creating a new instance of SignUpWebService, we will make this method accept this object as a method argument, or we can use other dependency injection strategies and inject this dependency using constructor-based dependency injection or field dependency injection. So when we need to write a unit test that tests the behavior of a method, we need to isolate this method from other dependencies. These dependencies are injected into our methods as stubs or mock objects with predefined behavior. We are not interested in testing these dependencies. We are only interested in testing code in the method under the test, isolated from all other dependencies. This way, our unit test that is testing this particular method is more reliable. And you will see how it all works in practice in following video lessons. To test your application, you might want to write 3 different types of test code, as illustrated in this pyramid. Notice that unit tests are at the bottom of the testing pyramid. And this is because usually unit tests are written and run before any other test code. So the first type of test code is unit test. And usually you will write a lot more unit tests for your application than any other tests. When running test code, unit tests are also the fastest among these three. This is because unit tests do not need to connect to a database and they do not need to send a HTTP request over the network and wait for a response. The next type of test code that you might want to write is called integration tests. And these test methods are very similar to unit tests, except that in this case you will not use mock and you will not use fake objects instead of real objects. The method you are testing will actually send a HTTP request if it needs to, or it will actually write into a database if it needs to. And in this case, if unit test did pass, then you are confident that the method you were testing will work well when it is integrated with other external systems. Alright, so in case of integration tests, if your method needs to load data from a database, or if your test method needs to send a HTTP request to fetch data from a remote server, you will not use fake objects anymore, but you will actually let your function use a real database connection or send a real HTTP request and work with a real HTTP response that it gets from the server. Integration tests run slower than unit tests because they need to communicate with other internal or external systems. The next level of testing that you will do is automated end-to-end testing. When doing end-to-end testing, you will test software functionality from beginning to end. If you are building mobile application, for example, or a web page, then you might want to write automated UI tests. These tests will test functionality of your application by actually invoking button clicks and evaluating if that button click did produce an expected result. So automated end-to-end tests run even slower, and the number of end-to-end tests that we create will be a lot less than the number of unit tests. So what is JUnit 5? The first answer that comes to mind is that it is a testing framework that allows us to write unit tests in Java, which is true. Let's have a look at its architecture. JUnit 5 is a combination of three things. It is a combination of JUnit Platform, JUnit Jupyter API, and JUnit Vintage Test Engine. The first component of JUnit 5 is JUnit Platform. It is a core platform that serves as a foundation for launching testing frameworks on JVM, and it provides a test engine for developing and running testing framework on the platform. Most popular Java development environments like NetBeans, IntelliJ, Eclipse, and build tools like Gradle, Maven, and Ant, they all provide first-class support for JUnit Platform, and we can use these tools today to run JUnit tests. Alright, so think of it as a platform that runs JUnit tests that you create. The second component is JUnit Jupyter API, and it is a combination of a new programming model and extension model for writing tests and extensions in JUnit 5. So Jupyter is a name of the API, and Jupyter API is what we use to write unit tests in Java. These are different test annotations and assertions that we use in our test methods. And then it also has an extension API that allows us to create our own version of test API that we can use additionally to Jupyter. The third component is JUnit Vintage. JUnit Vintage is a test engine for running older unit tests. Before JUnit 5, there were JUnit 3 and JUnit 4, so JUnit Vintage provides us with a test engine to run JUnit test methods written with older version of JUnit API. Because of JUnit Vintage, we can have a project that contains unit tests written with older JUnit API and JUnit methods written with a newer API version called Jupyter. Alright, so together these three components make up JUnit 5 that we will use in this video course.